Hello. In this last video, we're going to look at problematic equations. These are equations that we can't factor. So for example, we have this 9x squared minus 3x minus 1 equals 0 from the last video. Wasn't able to factor it there. So I'll try to use the quadratic formula. And if our quadratic is in standard form, then our solutions are x equals, and plugging in our a, b, and c. So negative 3 plus or minus the square root, negative 3 squared minus 4 times 9 times negative 1, all over 2 times 9. Now, while you're plugging in these values, it's very easy, especially with these negatives, to mess up with the negative b part, and especially so with this b squared. And that's why I suggest put all of these in parentheses until you really get the hang of it. So I'll continue simplifying. Negative 3 squared is 9. Negative 4 times 9 times negative 1 is 36, all over 18. So that's 3 plus or minus the square root of 45 over 18. And at this point, you might think we're done. But just like with fractions that aren't fully reduced, this is not fully reduced because of the square root of 45. So if you don't remember how to do prime factorization, where we have these trees, and we're trying to figure out what multiply together to be our top number, and we continue doing that until we get all primes. So 3 times 3 times 5 is 45. And now I have a pair. So I can reduce the square root of 45 to 3 times the square root of 5. And if I do that, I get this. So the reason that we reduce these square roots is because now you can see on the top, I could factor out 3. And on the bottom, I could factor out 3. And you can see how, just like with fractions that aren't fully reduced, now that I've done that, I can fully reduce the fraction. And I'm left with 1 plus or minus the square root of 5 divided by 6. So our quadratic goes through the x-axis twice at these 2 points. And you can see we definitely weren't going to be able to factor it, because this is saying that our factored form for the quadratic looks like y equals, there's that a, x minus, let's say the positive version, and x minus the negative version. So there's no way we could have factored it, because there's no way we would have guessed this pair. So we can see why the quadratic formula would be useful. Now, I do want to caution, it's not always best to use the quadratic formula. It does always work, and I'll write that down. The quadratic formula always works, so it may be tempting to always use the quadratic formula to solve quadratic equations. But let's look at something like this. If you remember from the last video or from Module 2 with factoring trinomials, you can factor this. You can pull out the 3 and then you can factor. And it really wasn't that challenging. But if I try to use the quadratic formula, I end up with some really large numbers. Now, for us, we'll always have a calculator, so that's okay. But 33 squared is a really large number, and I'd rather not square that number, multiply all of these out, subtract it, take the square root of that, when I could have just factored it from the first place. So I'll stop this one here. It can be factored, so you should factor it when you can. But when we can't, or maybe you're having trouble factoring, you can always rely on the quadratic formula. So one last example for this video. X squared minus 8x plus 19. It'd be really nice if this could factor. Right? We'd look for two numbers that multiply to be 19 and add to be negative 8. Well, since 19 is prime, this is going to be very easy to list all of them. We definitely can't factor this equation. So we'll try to use quadratic formula. Negative b plus or minus the square root, negative b squared minus 4 times a times c all over 2a. And you might be able to see where this is going. And what I'm left with now is the square root of a negative number. This is a complex number. It's not real. And what this tells me is that this has no real solutions. So by using the quadratic formula and really just doing the part underneath the square root, that's b squared minus 4ac, you could figure out if the parabola doesn't touch the x-axis. Because if it doesn't touch the x-axis, it has no solutions. All right, and that's everything for quadratic equations.